Hello and welcome to our new video on exploring the vastness of the visible universe. In this video, we will take you on a journey through space and time. From the smallest subatomic particles to the largest superclusters of galaxies, from the earliest moments of the universe to the present day, and from our own solar system to the farthest reaches of the cosmos. We will also show you how scientists observe and measure the observable universe using different instruments and methods, and what are some of the challenges and mysteries that they face in doing so. Prepare to be astonished by the amazing wonders and mysteries of our cosmic home. The universe is everything that exists, from the smallest subatomic particles to the largest superclusters of galaxies. It is incredibly vast and possibly infinite in size. However, we cannot see or observe everything in the universe because of a fundamental limit imposed by the speed of light. Light is the fastest thing in the universe, traveling at about 300,000 kilometers per second, or 186,000 miles per second. This means that it takes time for light to reach us from distant objects. For example, it takes about 8 minutes for light to reach us from the sun, which is about 150 million kilometers or 93 million miles away from us. It takes about 4 years for light to reach us from the nearest star, Proxima Centauri, which is about 40 trillion kilometers or 25 trillion miles away from us. And it takes about 2.5 million years for light to reach us from the nearest galaxy, Andromeda, which is about 2.5 million light years away from us. This means that when we look at distant objects in the sky, we are actually seeing them as they were in the past, not as they are now. We are seeing snapshots of their history, not their present. The farther away an object is, the older its image is. This also means that there is a limit to how far back in time we can see. The oldest light that we can see comes from the cosmic microwave background radiation, CMBR, which is a faint glow of microwave radiation that fills the entire sky. The CMBR was emitted when the universe was about 380,000 years old and became transparent for the first time after a long period of being opaque like thick fog. The CMBR gives us a snapshot of how the universe looked like at that early stage of its evolution. The region of space that contains all the matter and energy that we can observe at the present time is called the Observable Universe. It is a ball-shaped region centered on us, with a radius of about 46 billion light years and a diameter of about 93 billion light years. That's a huge distance, but it may be only a tiny fraction of the entire universe, which could be infinite or have a much larger size than we can ever see. The observable universe is constantly changing over time as new regions of space become visible to us and some objects disappear beyond our horizon. The observable universe contains several hundred billion galaxies, each with billions or trillions of stars and planets. The observable universe also contains different types of matter and energy, each with its own properties and effects. The most familiar type of matter is ordinary matter, which makes up everything we see around us, such as stars, planets, galaxies, and ourselves. Ordinary matter accounts for only about 4.9% of the total mass energy of the observable universe. The rest is made up of dark matter and dark energy, which are mysterious substances that we cannot directly observe but can infer from their gravitational influence on ordinary matter. Dark matter makes up about 26.8% of the mass energy of the observable universe and helps to hold together galaxies and clusters of galaxies. Dark energy makes up about 68.3% of the mass energy of the observable universe and causes the expansion of the universe to accelerate over time. The observable universe has a complex and diverse structure and distribution of matter and energy, ranging from the smallest subatomic particles to the largest superclusters of galaxies. The The smallest known particles are quarks and leptons, which make up protons, neutrons, electrons, and other elementary particles. The largest known structure is the Hercules corona Borealis Great Wall, which is a giant filament of galaxies that spans about 10 billion light-years across. Between these extremes, there are many other levels of organization and hierarchy, such as atoms, molecules, cells, organisms, planets, stars, solar systems, galaxies, groups, clusters, filaments, walls, and voids, etc. Observing the observable universe is not without its challenges and limitations. One of the main challenges is that we cannot see beyond a certain distance or time because of the finite speed of light. This means that there is a limit to how far back in time we can look at the observable universe. Another challenge is that distant objects appear more redshifted and dimmer as they move away from us, due to the expansion of space. This makes them harder to detect and analyze with our instruments. Another challenge is that there are some problems and puzzles that arise from our observations of the observable universe, such as why it appears to be almost uniform and isotropic on large scales, despite having regions that could not have been in causal contact with each other, the horizon problem, or why it has fluctuations in temperature and density that give rise to structures such as galaxies and clusters, the cosmic variance problem. To overcome some of these challenges and limitations, cosmologists use various techniques and strategies to improve their observations and understanding of the observable universe. One technique is to use different wavelengths of radiation to probe different aspects and features of the observable universe that are otherwise invisible or obscured by dust or gas. Another technique is to combine multiple observations from different instruments or locations to get a completer and more accurate picture of the observable universe. Another technique is to apply statistical methods and models to analyze large sets of data from observations and simulations to infer patterns and properties of the observable universe. To answer some of the questions and mysteries that remain unanswered and unresolved, scientists are constantly developing new instruments and experiments that aim to explore the observable universe further and deeper. Some of the current and future projects are the James Webb Space Telescope, JWST, which will observe the infrared radiation from some of the earliest and most distant objects in the observable universe, the Square Kilometer Array, SKA, which will be the world's largest radio telescope, capable of detecting faint radio signals from billions of light-years away. The Large Synoptic Survey Telescope, LSST, which will survey the entire visible sky every few nights, creating a detailed map of the observable universe. The Laser Interferometer Space Antenna, LISA, which will detect gravitational waves from massive objects, such as black holes and neutron stars. The Dark Energy Survey, DES, which will measure the effects of dark energy on the expansion and structure of the observable universe. These projects and many others will help us to learn more about the observable universe and its vastness. They will also help us to test and refine our physical theories and models of the universe, explore our cosmic origins and history, find potential habitable planets and extraterrestrial life, inspire curiosity and wonder, and expand our horizons. I hope you enjoyed this video on exploring the vastness of the visible universe. If you did, please like, subscribe, and share this video with your friends. And if you have any questions or comments, please leave them below. Thank you for watching, and see you next time.